Hello students, my name is Arshan and today we are gonna do the 6th chapter from your mathematics textbook of NCERT for class 7th. And the name of the 6th chapter is the triangle and its properties. So students, a triangle, you might have seen, is a simple closed curve made of 3 line segments. It has 3 vertices, 3 sides and 3 angles. Now here is a triangle ABC. It has sides AB, BC, CA and angles BAC, ABC and angle BCA with vertices A, B and C. Now the side opposite to the vertex A is BC and the angle opposite to the side AB is, yes, this one. Now you know how to classify triangles based on the sides, angles. Based on the sides, triangles are of 3 types, that is scalene, isosceles and equilateral triangles. And based on angles, triangles are of 3 types, that is acute, angled, obtuse angled and right angled triangles. Now on the topic of medians of a triangle. Given a line segment, you know how to find its perpendicular bisector by the paper folding. Can you cut out a triangle ABC from a piece of paper and consider any one of its sides, say BC. By paper folding, locate the perpendicular bisector of BC. The folded crease meets BC at D, its midpoint. And now we will join A to D with line AD. The line segment AD joining the midpoint of BC to its opposite vertex A is called a median of the triangle. Now consider the sides AB and CA and find 2 more medians of a triangle. I am sure you can do these activities at your home in your notebook. Now students, we can also say that a median is the line that connects a vertex of a triangle to the midpoint of the opposite side. Now altitude of a triangle. Students, make a triangle ABC, place it upright on a table. Now, how tall is the triangle? The height is the distance from vertex A to the base BC. From A to BC, can we think of many line segments? Well, certainly not. Now, to determine the height of the triangle, we can say that the height is given by the line segment that starts from A, comes straight down to BC and is perpendicular to BC. This line segment AL is an altitude of the triangle. An altitude has one endpoint at a vertex of the triangle and other on the line containing the opposite side through each vertex. An altitude can be drawn like this. Now students, on to the topic of exterior angle of a triangle and its properties. Consider triangle ABC. Now in this triangle, angle ACD is an exterior angle. Now we have to show that angle ACD is equals to angle A plus angle B. So we will draw a line, that is CE through C, which is parallel to BA. Now students, the steps. We can say that angle 1 is equals to angle X because BA is parallel to CE and AC is a transversal line. Therefore, alternate angles should be equal. Now, angle 2 is equals to angle Y because BA is parallel to CE and BD is a transversal line. Therefore, corresponding angles should be equal. We have learned these properties in chapter 5. Now we can say that angle 1 plus 2 is equals to angle X is equals to angle Y. Similarly, we can say that angle X plus Y is equals to angle ACD. Hence, angle 1 plus angle 2 is equals to angle ACD. So students, we can say that via this exercise, an exterior angle and its 2 interior opposite angles is referred to as exterior angle property of a triangle. That is, angle 1 plus angle 2 is equals to angle ACD. With this students, we are on to the angle sum property of a triangle. There is a remarkable property connecting the 3 angles of a triangle. We will see this through the following 4 activities. First, we will draw a triangle. We will cut on the 3 angles. rearrange them like this. This angle is a straight angle and so has measure 180 degree. Thus, the sum of the measures of the three angles of a triangle is 180 degrees. The same fact you can observe in a different way also, students. We can take three copies of any triangle, say a triangle ABC. We will arrange them like this. Now in this we will take a piece of paper and cut out a triangle, say a triangle ABC, and we will make the altitude AM by folding triangle ABC such that it passes through A. Now we will fold the three corners such that the three vertices A, B and C touch at M. We can see that the three angles form together a straight angle. This again shows that the sum of the measures of the three angle of a triangle is 180 degrees. Now students, we will draw three triangles, that is triangle ABC, triangle PQR and triangle XYZ. You people can also draw these triangles into your notebook. When perfect precision is possible, this will also show that the sum of the measures of the three angles of a triangle is 180 degrees. Now students, we can justify these statements with the help of exterior angle property of a triangle. Now given angle 1, angle 2 and angle 3 are angles of triangle ABC, and angle 4 is the exterior angle when BC is extended to D. Angle 1 plus angle 2 is equals to angle 4, that is by exterior angle property. Then angle 1 plus angle 2 plus angle 3 is equals to angle 4 plus angle 3 if we add angle 3 to both the sides. But angle 4 and angle 3 forms a linear pair, so it is 180 degree. Therefore, we can say that angle 1 plus angle 2 plus angle 3 is equals to 180 degrees. Hence, it is justified. With this students, on to the topic of sum of the lengths of two sides of a triangle. We will mark three non-collinear points A, B and C. Now, using our pen, we will mark the paths AB, BC and AC. Now, we will see or we will measure the lengths of AB, BC and AC. Sum of any two sides is always greater than the third side. So, we can also say that AB plus BC is greater than AC. Similarly, if we were to start from B and go to A, we can say that BC plus CA is greater than AB. And similarly, we can also write that CA plus AB is greater than BC. With this, we also find that the difference between the length of any two sides of a triangle is smaller than the length of the third side. So, to confirm our observation, let us perform this example. In this, we will take a triangle whose sides have lengths say 10.2 cm, 5.8 cm and 4.5 cm. And we will suppose that such a triangle is possible. Then, the sum of the lengths of any two sides would be greater than the length of the third side. Let us check this out. Now, is 4.5 plus 5.8 greater than 10.2? Yes, it is. So, similarly, is 5.8 plus 10.2 greater than 4.5? Yes, it is. Similarly, is 10.2 plus 4.5 greater than 5.8? Yes, therefore, the triangle is possible. Hence, we can say that our assumption was right. With this students, on to the topic of right angle triangles and the Pythagoras property. Pythagoras, a Greek philosopher of 6th century BC, is said to have found a very important and useful property of right angled triangles, which we will learn in this section. The property is hence named after him. In fact, this property was known to people of many other countries too. We will now try to explain the Pythagoras property. So students, in a right angled triangle, the sides have some special names. The side opposite to the right angle is called the hypotenuse, and the other two sides are known as the legs of the right angled triangle. Now in this triangle ABC, the right angle is at B, so AC is the hypotenuse. AB and BC are the legs of triangle ABC. We will try to make identical copies of right angle triangle of any size we prefer. For example, we can make a right angle triangle whose hypotenuse is a unit long and the lengths are of unit B and C units. Similarly, we can draw two identical squares on a sheet of paper with sides of length B plus C. So we can see that if we place 4 triangles in one square and the remaining 4 triangles in another square, we can see that the squares are identical. Hence, the 8 triangles inserted are also identical. Hence, we can say that the uncovered area of the square A is equals to uncovered area of square B, that is, area of inner square of square A is equals to the total area of 2 uncovered squares in square B. So, A2 is equals to B2 plus C2. So, we can say that A square is equals to B square plus C square. It may also be stated as follows, that in a right angle triangle, the square on the hypotenuse is equal to the sum of the square on the legs of the triangle. Now, Pythagoras property is a very useful tool in mathematics. It is formally proved as a theorem in later classes. You students should be clear about its meaning. It says that for any right angle triangle, the area of the square on the hypotenuse is equal to the sum of the areas of the square on the legs. Now, on a clean sheet of paper, try to make a right angle and compute the area of the squares and verify the theorem. If we have a right angle triangle, the Pythagoras property holds. If the Pythagoras property holds for some triangle, will the triangle be right angled? Well, certainly yes, it will be. Now, these type of problems are known as converse problems. We can say that if a triangle whose sum of the squares on 2 of its sides is equal to the square of the third side, then it must be a right angle triangle. Now students, we will perform some examples to solidify what we have learned and to understand this concept more thoroughly. So, we will determine whether the triangle whose length of sides are 3 cm, 4 cm and 5 cm is a right angle triangle or not. So students, for the solution of this problem, we will check out whether the square of the sides is equal to the square of the hypotenuse. And now as we know that hypotenuse in a right angle triangle is the longest side. Hence, we will do the square of 3 and 4, add it and will compare to the square of the longest side, that is 5. So the square of 3 is 9 and the square of 4 is 16. So we will add 9 and 16, which is 25, which is equal to the square of 5, that is the hypotenuse. Hence, we can say that it is a right angle triangle. So, with this students, we are at the end of this chapter. Now, in this chapter, we have learned very interesting things. We have learned that the 6 elements of a triangle are its 3 angles and 3 sides. The line segment joining a vertex of a triangle to the midpoint of its opposite side is called a median of the triangle, and a triangle has 3 medians. The perpendicular line segment from a vertex of a triangle to its opposite side is called an altitude of the triangle. A triangle has 3 altitudes. An exterior angle of a triangle is formed when a side of a triangle is produced. At each vertex, we have 2 ways of forming an exterior angle. Also, we have learned the property of exterior angles. That is, the measure of any exterior angle of a triangle is equal to the sum of the measures of its interior opposite angles. We have also learned the angle sum property of a triangle. That is, the total measure of all the angles of a triangle is equals to 180 degrees. Now, a triangle is said to be, also in this chapter we have learned that a triangle is said to be an equilateral triangle if each one of its sides has the same length, and in an equilateral triangle each angle has a measure of 60 degrees. Also, we have learned that a triangle is said to be isosceles if at least any 2 of its sides are of same length. The non-equal side of an isosceles triangle is called its base. The base angle of an isosceles triangle have equal measure. Now, we have also learned the property of the length of sides of a triangle, which is the difference between the length of any 2 sides is smaller than the length of the third side. This property is useful to know that is it possible to draw a triangle when the lengths of the 3 sides are known. Now, also in this chapter we have learned about the right angled triangle, and also that the side opposite to the right angle is called the hypotenuse and the other 2 sides are called its legs. And in this chapter, we have learned the Pythagoras property, which is in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on its legs. If a triangle is not right angled, this property does not hold good. The property is useful to decide whether a given triangle is right angled or not. With this, students, we are at the end of this chapter, and I am sure that you will practice all these concepts and all these exercises in your notebook. Try to do these questions on your own. You may take the help of your parents or your teachers. So students, we will meet next time with some other interesting topic. Till then, I will take your leave. Bye bye.